G'day folks. Well, for today's equipment autopsy, I figured we'd strip down this old Fujitsu Inverter indoor unit. Obviously an air conditioning head unit for a inverter based Fujitsu air conditioning system. Roughly 6.5 to 7 kilowatts capacity. I'm not 100% sure on that. There is a sticker on there, but what does it say? It just has data on its recommended outdoor unit, which was an AOT 30PMAL R22 refrigerant made in Kawasaki, Japan. Fairly reasonable quality units, but the inverters fail them. That's one of the biggest problems with all these new air conditioners. As soon as you get a lot of ambient moisture or salt air, they die. I've scrapped so many of them. There's even an inverter unit from a LG VRV twin compressor system. It has start and run capacitors for a big AC compressor, and it also has a VFD for a smaller sub-compressor. 2 compressors. That failed, and the whole unit was scrapped. Not a good thing. I don't like inverter units, but we're going to strip this whole thing down just for the fun of it. There is no inverter in here. That belongs in the condensing unit. But we'll have a look at what's inside this one, which also has a lot of electronics that are known to fail. As you can tell, I'm not a big fan of that. I like the old 1970s, 1980s conventional window shakers and central systems, which have very, very basic electrical thermostatic controls, and that's about it. No fancy printed circuit boards apart from maybe a defrost board. That's it. I don't like this fantastic plastic stuff, so let's rip this thing to pieces and see what it does. I guess we'd start from the outside. This is the back of the unit. We've got a mounting bracket or plate. This isn't the right one for this indoor unit, but they all look similar. They just have a grid of holes which you can screw into the existing wall studs, that sort of thing. You rarely find one which you can't locate a couple of wall studs to bolt it to. Like, it's just between centres, measurement between centres, and it should, if it was the right one, it would just snap up into the bottom of this housing like that and snap into the bottom. But this is the wrong one for this indoor unit. This is for a Panasonic unit, which I still have. It's for a very good Panasonic unit, which does not use an inverter. So, yeah, of course we've got the line set out here. That's the liquid evaporation line. As in split systems, the evaporation starts out outside in the condenser. There is no thermal expansion point or orifice inside this unit for expansion. It all happens outdoors. And that's the suction line, which isn't actually that much different in size, which is quite surprising. Unless they've hacked it and soldered the wrong size one on there, but it doesn't look like it. No. And that spring stuff's just so that you can bend the tubes to get them through the wall without actually kinking and cracking them. It's a pipe bending spring. So twist that all the way around, and look, no kink. It's kind of handy how they do that. But yeah, that's the back of the unit. Front of the unit I'll open up and we'll go from there. Alright, looking at it from the front, you should see the front panel with a couple of filters installed. These aren't the right ones for this unit. I've already scavenged them for something else. They're from, I think, one of those, which is a slightly larger unit again. Again, non-inverter. I don't run inverters in this workshop. I only use the old alternating current, regular hermetic compressors. Well, they're all hermetic, but the DC inverter compressors are a small twin rotor permanent magnet unit. They are efficient in low ambient temperatures and things like that, but where I live, the inverter boards themselves just die, so I stay away from them and stick with normal reciprocating or twin rotor compressor units, or single rotor compressor units. But yeah, we have filters in here. They normally slot down to there and screen any large particles so they can come out. Front panel's pretty simple, obvious. It's just a plastic screen really. It's cosmetics. Yeah, you got air diffuser flaps. Normally I would not recommend moving them yourself because they are on a stepping motor, and if the stepping motor loses its home position it will do weird things, like it'll shut when it's supposed to be wide open. So yeah, if you do find one that's open, don't push it shut or do anything like that, because your stepping motor will lose its home position. But yeah, same with these things here. These are on stepping motors as well. Air wave diffusers. This whole thing's mouldy as hell. Yeah, yuck. That's why I don't like a lot of split systems. They are mouldy, they are nasty. This one's been sitting around the backyard for ages. That's the electrical terminal box, mains connections, and outdoor unit. There isn't really much more than that. There is live and neutral power, and that is I think it's serial communication or something like that. It is not just like a 5-volt command on frequency, or sorry, power. It's actually a command frequency from the board itself, from the CPU. It sends a control frequency out to the outdoor unit to tell it what to do, whether it wants to go into heat, cool, defrost, fan only, whatever. Yeah, it's a serial communication thing, I believe. I might be wrong, but that's why it's so hard to run the condensing units without this indoor unit. In theory I should keep this in one piece so I can test those outdoor units, but really I have no interest in them anyway, so might as well make them all die. I spent half the day scrapping air conditioners at the junkyard, so I've seen enough dead inverter units today to satisfy my liking. Pile of dead everything, that's what I like. It's all scrap to me. Alright, now that I've scun it, which is pretty easy, just remove all the front panel screws, top and bottom, and just peel the front cover off it. Pretty easy to see how it's made up. You have a wraparound coil unit over the top. That's all indicator LEDs and infrared sensor for the remote. That's about all that's in there. Again, that's our control interface. Isolating, or not isolating, but low voltage DC transformer for the control voltage, which would either be 12 or 24 volts. There's a couple of stepping motors, yeah, 12 volt stepping motors, so that'll be a 12 volt transformer for all this stuff, for the control board in there. Yeah, and these servos or stepping motors control the flap or air diffuser flaps. One there, and there should be a third one somewhere. Oh yeah, down there. That's the air wave motor. So there's 3 tiny little stepping motors and a main fan motor down in there. So I think we'll pull that out next, pull this electrical box out, then we'll look at separating the coil and the fan itself. Another thing to note is that these thermistors here are for sampling temperature coming off the refrigerant in the system, like that one there. And there should also be an indoor air sampling thermistor somewhere. Where is it? I wonder if it's in here. There's supposed to be an indoor air sampling thermistor somewhere, but I don't know where that one is at the moment. Oh, there he is. He's right in there. That is indoor air temperature monitoring. That's what it reads on the display and what it uses to calculate whether or not to run, whether or not to go into heat or cool mode, that sort of thing. That would be to do with heating and cooling mode, or fan speed. Yeah, once this coil reaches a certain temperature in heat mode, it will tell it to go to high fan, or once it reaches a certain temperature in cool mode, it should tell it to go to high fan. These won't go to high fan unless, say, if you're in heat mode, these will not go to high fan until that thermistor tells it that the coil is getting hot, so it won't blow cold air while the unit's coming up to temperature and pressure. I know it sends the head pressure of the compressor and everything sky high, which is probably not ideal, but it just saves having cold air blown at you while the unit's still coming up. So in a way it's not too bad. And you can simply remove them like that. They sort of look like a detonator. Don't know why that is. Then again, a good friend of mine is a blaster, so I'm kind of familiar with things like that going bang, but that's actually a thermistor. And so is that little thing there.